Hello, and welcome to my new series of videos taking you through the design process of an oscilloscope. In the first episode, I'll go through the basics of what an oscilloscope has and how it will work. In the next video, I'll design the schematics in PCB, and then lastly, we'll test and program the device. But what is an oscilloscope? Here is a picture of an oscilloscope. It is a tool that measures voltage and graphs it against time. Let's have a look at what parts an oscilloscope generally has. So, arguably the most important feature of an oscilloscope is the analog inputs. This is what the oscilloscope uses to connect to your circuit and measure the voltage. Next, we have the display. Let's have a look at what is on these screens then. Here is a screenshot of an oscilloscope screen. The most important part that you can see is the graph. This shows time on the x-axis and voltage or potential difference on the y. This picture is a bit difficult as it has 4 different lines, but they are all either 5 or 0 volts. This is because it has to display all the inputs that are being used somehow. Just below that, we have information on these input pins. For example, the frequency, max and minimum voltage for the current time, and the average voltage. This is just something to help the engineer out reading the signals. And finally, we have the square markers. These are used to once again help the engineer read the signal. In short, an oscilloscope reads voltages millions of times a second and displays it. It could be used to debug circuits or even reverse engineer products. In part 2, we are going to explain how this works. So firstly, we have a problem. Computers cannot directly understand analog or constantly changing values. I present you an analog to digital converter, or ADC. This converts your constantly changing voltage from 0 to 3.3 volts to a nice, easily readable value for computers. This chip has a resolution of 14 bits and can measure 2.5 million times per second. That's smaller than most oscilloscopes, but it is good enough for beginners. Having a bit depth of 14 means it can tell when the voltage increases or decreases by 201.4 microvolts. That is more than accurate enough for our purposes. But what about connecting it to the computer? Oh yeah, the screen will be on the computer via USB. Well, we're going to use an RP2040, which is a microcontroller, or MCU, designed in Cambridge by Raspberry Pi. It has a dual-core CPU, lots of RAM, which is very useful for our needs, a very fast clock speed, built-in USB, and programmable I/O, or PIO. Well, what is PIO? PIO, or programmable input-output, allows us to create super fast communications between the ADC and RP2040. Well, now we have a new problem. The USB protocol is actually not fast enough for our purpose, so instead what can we use? Well, I think we should use SD cards. They are fast enough for our use and have lots of storage. So, we will record the ADC to the SD card. That sounds pretty good, doesn't it? Ah yes, the user cannot see what they are recording, but that's okay. The RP2040 has a solution for this. It has its own analog to digital converter, which is slow enough to fit on the USB's data connection. This brings to question though, why can't we use the RP2040's analog to digital converter for the oscilloscope? Well, we could, but whilst being slower, the bit depth of the ADC is also lower, so it is not as accurate. And finally, here is a simple block diagram of our oscilloscope. The USB and RP2040 are directly connected and use the USB protocol, whereas the SD card is connected to the RP2040 via the SPI protocol, or Serial Peripheral Interface Protocol. This is the same with the analog to digital converter, but it is only in one direction. Going into the analog to digital converter is a ±5 to 0 to going into the analog to digital converter is a ±5 to 0 to 3.3 volt converter. This is so that we can measure a wider range of voltages. And finally, going into that is the analog signal itself. That's the end of episode 1. And now a message from our sponsor, PCBWay. Right now, in October, they are offering a free purple silkscreen. This can make your project look very cool. As well as that, they offer 3D printing, CNC machining, and even sheet metal bending. You can get your PCBs assembled from $29 and made from $5. If you're interested in PCBWay services, take a look at the website on screen or in the description below. Thanks to PCBWay for sponsoring this series and half the other channels on YouTube. Shh. In the next episode of this series, we are going to design some schematics and PCBs for our oscilloscope. Thanks for watching, and I hope to see you again in the next episode.